welcome to the RPS project. I'm going to be continuing my look at turning on a transistor but using capacitors and resistor divider on the base. So really this is, well, it's really more about capacitors than it is transistors. But what I'm going to do is the same as I've done last time, the last couple of videos, which if you want to see, go check them out. But there's one big difference, is that I'm going to use multiple capacitors. I'm going to use them in series and in parallel. So have a quick look on the whiteboard and see what I'm talking about. So a quick look at the circuit we're using. Very simple. NPN transistor. I've got a LED up there. Resistor. That's down to ground. And on the base, basically I've got resistor plus 5 volts up there. So it's the same as what I've been using the last couple of videos, but this time when we come to the capacitance, I'm going to either have a bunch of them in series, or a bunch of them in parallel. So it's pretty simple, you know. It's nothing spectacular, but it should do the job and give me some entertainment, give me something to look at on the scope, so I can see what's going on. So let's go and have a look at that. So I've got my little setup here. I've got transistor, LED. I'm just using a what am I using? Well, it's just some small dropper resistor for the LED, and then I'm using a 100k as part of the circuit coming onto the base, and then after the base it'll be a bunch of capacitors, which I've got a whole bunch here. Got some little ones, some 1 microfarad capacitors, all the way up to these big chunky 1000 microfarad capacitors. I'm only using 5 volts, so all this will be just fine. You know, I'm going to change the camera angle now, and I'm going to put it onto the scope, which is just over there, so we can see what the real business is all about. So I've got the scope turned on, got my circuit set up, all ready to go. Now, obviously nothing turned on at the moment, so let's turn on channel 1. There we go. Oh, it looks a bit rubbish because, well, basically there's nothing in the circuit. The capacitor's not in there, so I better put a capacitor in, like a 1 microfarad. Give it a bit of stability in there. There we go. That's a bit better. Marvellous. So yeah, I suppose all I've got to do now is set it to capture on the scope and turn it on. So ready, and there we go. But obviously I'm completely off the scale, so I'm going to have to reset this. My trigger point is like that way by a mile or so, so I'll just fiddle around and get this set right. So let's turn that off and bring this in. As you can see, it's miles out. I've been obviously messing about quite a bit, so this is like hugely off. So I've got to bring that all the way down, cranking it down forever and ever. Okay, now I've got my trigger set somewhere sensible. Let's do that again. Get it reset. It's ready to go. Let's turn it on. There we go. That's nice. It's a nice turn on. Good ramp. So let's see how long that single 1 microfarad capacitor took to charge up. And because I'm using a transistor here, then that voltage is going to be about 700 700 millivolts, just because it doesn't need to be anything else. So yeah, it's about 1.98 milliseconds, literally just under 2 milliseconds. So yeah, that's brilliant. It does what I want it to, one capacitor. So I suppose if I shove another capacitor in there, but this time I'm going to put it in series. You know, you put stuff in series. So let's just turn those cursors off a moment. Turn that off. Reset. And shove another capacitor in there. Another 1 microfarad. And we're going to turn it on again. I'm going to leave the settings as they were before because it should really pick it up from this, because all we've done is increase the capacitance to 2. And there we go. That does look a much shorter, much sharper turn on than the previous one. So back with the cursors, and last time it was 1.98, and this time we've got about there, got about 1 millisecond, so it's about 2 milliseconds before, and this one's about 1. So two capacitors that I've got have given me this sharper ramp, because 2 capacitors in series is halving your capacitance, so I got less capacitance, so it charges quicker. Brilliant. So I suppose let's put a bunch of these in parallel. Well, let's put 2 of them in parallel. I mean, I've shown that basically if I put them in series, I have my capacitance. So if I put these same 2 capacitors in parallel, then I should double it. Now, first time off it was just under 2 milliseconds, so I should be somewhere just under 4 milliseconds. That's ready. On we go. It's all quite clearly a longer ramp for this time, for the same 2 capacitors, only this time they're in parallel and not in series. So parallel capacitors. I've obviously got a lot more capacitance going on there, and that's given me about, yeah, look at that, 3.99. so yeah, 4. So 1 capacitor gave me, 1 microfarad capacitor gave me about 2 milliseconds on the ramp. 2 capacitors in series gave me about 1 millisecond on that ramp, and 2 capacitors, 1 microfarad capacitors in parallel give me 4. So brilliant, that does exactly what I want it to. So let's try a different capacitance. What shall I try though? I'm going to go with something huge. I'm going to go with the big capacitors. I've got some big chunky 1000 microfarads. I'm actually going to shove all 4 of these in. If I can get them in series somehow. So I'll just get that set up. Okay, so I've got my 4 capacitors set up down there on my breadboard, and I've changed my time base to 100 milliseconds because we've got much more capacitance here. This is going to take a long time to, in electronics terms, it's going to take a long time to turn on. So we'll set that, and it's come on, and there we go. Wow, in real terms, that actually took quite some time to come on. So let's just have a look at how long that actually took. Don't forget, this time we're in 100 milliseconds. Last time the time base was 500 microseconds. So this is taking 400 and, well, yeah, it's about 460 milliseconds. That's nearly half a second for those 4 capacitors to charge up, and they're in series. So if you think about it, I've got 1000 microfarads in series, which is equivalent, so 1000 divided by 4 is equivalent to 250 microfarads. Now I've got some hundreds and a 47 microfarads, so I'm going to swap out these 4 1000 microfarad capacitors for 2 100 microfarads and a 47 microfarad capacitor in parallel. and by rights it should give me the same result. So let's go and do it. Okay, here we go, all set up now. Basically, instead of four of these big chunky things in series, in parallel I've got two 100 microfarads and a 47 microfarad. So let's get it set, ready. There you go, marvellous. Took a bit of time to come up, didn't it? Just like the big ones did. But what's the time that it took? And I haven't moved that cursor at all. I haven't changed that. And as you can see, pretty much that slope is in exactly the same place. The cursor's in the same place it was 460 milliseconds. So nearly half a second. So 3 capacitors. So I suppose in the design theory, that would be less cost, wouldn't it? Because instead of having 4,000 microfarad capacitors in series, you'd have 3 smaller value capacitors doing the same thing. I think that proves my understanding of today's look at turning on this transistor with using capacitors. Yeah, brilliant. Does what it should be doing. Marvellous. What more can I say about that? So there you go. Capacitors, parallel and series. There's not a lot to it really. I suppose all that has shown really is that capacitors, you know, the theory holds up that if you have them in series, you reduce your capacitance. If you put them in parallel, you increase your capacitance, and I think that's shown that quite well on that demonstration, that testing I've done on the bench. So yeah, it does what I expected, which is brilliant. Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.